For the first time in nearly a quarter century, ESA's Rosetta mission will bring new information on one of the most mysterious of celestial bodies, comets. The objective is to carry an orbiter to comet 67P Churyumov-Gerasimenko and to place a lander on its surface. Comets are ice-rich bodies that become prominent when heat from the sun causes their trapped volatiles to sublimate. Then their most distinctive features, the coma and the tail, become visible. After having dropped a lander on the comet, the Rosetta orbiter will continue to move around it at many different positions.
JADA is the experiment on board the Rosetta mission explicitly dedicated to study the dust physical properties and dynamical properties of the grains once they are emitted from the nucleus. So the information that we expect from this experiment is quite relevant to understand the evolution of the dust from the comet environment.
University of Bern, end of September 2002. The Swiss scientist KATRIN ALTWEGG is managing the development of the Rosetta orbiter spectrometer for ion and neutral analysis, the so-called ROSENA.
What you see here is the ROSENA RTOF sensor. It's one of the 3 sensors of the ROSENA instrument. It's a mass spectrometer to analyze the chemical composition of the volatile material.
Another sensor on ROSENA is a pressure sensor that will measure the total pressure of the cometary gas to deduce the dynamics of the gas. This means the speed, the direction and the temperature of the comet outgassing. It will also be used as an alarm system to protect the other instruments. If the pressure gets too high, it will put all the instruments in safety mode. Comets are known as objects carrying a message from the time the planetary system was formed 4.5 billion years ago. Rosetta's analysis of the particles on the comet itself and in the comet's tail could bring confirmation of what has been discovered in laboratories.
We simulated the chemistry taking place in star formation regions where our solar system too was created. And to our surprise, there are lots of even amino acids under the organic material. These amino acids are known to be essential for life because they make up proteins which themselves are indispensable for any creature living on our planet or elsewhere.
At the Max Planck Institute, JOCHEN KISSEL has worked on the Cometary Secondary Ion Mass Analyzer, COSIMA, which will analyze whether dust grains emitted by the comet are organic or inorganic.
This funnel here is looking towards the comet, and the dust comes in, settles down on a little target which is behind here. And this machine here will, after some time, when enough dust is collected, will turn it around and move it here to this little camera. And this camera, called cosiscope, it will look at the target and find individual dust particles. Now then, the machine transfers this target far down into the instrument in front of an ion beam. And we select the charge and accelerate these ions into that tube here, this golden tube. Here are electric fields where they turn around, come back through this tube and end up at the detector. And this total flight time is a measure for the mass of these ions, and from these ion masses we conclude what this particle was made of.
Nobody knows what the surface of a comet looks like. Rosetta's lander will take 6 miniature cameras developed by the French space agency CNES. Using 3D technology, they will take panoramic pictures of the surface. Other instruments on the lander will analyze the cometary surface composition. At the Open University in London, Dr. Ian Wright developed Modulus Ptolemy, an evolved gas analyzer which obtains accurate measurements of light elements.
This is a model of our instrument which is going to descend down to the comet on board the lander. And along with 2 other instruments, it's involved with an integrated experiment to actually look close up at the comet and actually analyse the materials that it's made of. We're particularly interested to know whether it's composed of water and carbon-bearing molecules, particularly organic compounds and so on. And we're also interested in the relationship of the water in the comets to the water we find on Earth today. We want to know, are they in any way related or not? This whole thing constitutes a miniaturized laboratory.
But not all instruments to study the surface of the comet are placed on the lander. On board of the orbiter is the imaging spectrometer VIRTIS, developed by a group of scientists of the CNR in Rome that will also be devoted to studying the comet's surface.
VIRTIS will study the surface of the cometary nucleus when the cometary nucleus is not yet active. Usually when we look at the comets, we see the intense activity that characterizes their life when they are near the Sun. However, it's very difficult to observe the small object that is the origin of this activity. We don't know it. The only measurements that were done during the Giotto mission. With VIRTIS we will be able to image and at the same time to identify the composition of the material present on the cometary nucleus. For example, we will be able to distinguish active areas that are probably characterized by the surface presence of ice material from areas that are instead covered by dust.
By combining the analysis made of the surface and those of the comet's tails, scientists should gain a complete picture of the physical and chemical processes on the comet and how it could have brought life to Earth.